Okay guys, so this is a second example talking about increasing, decreasing constant and any sort of relative maximums or minimums. You can see it's more or less already labeled and answered, possibly because in the first attempt at this video I said something wrong at the very end and had to redo it. Or for other reasons, who's to say? It's just a mystery, I guess. It's lost to time. Regardless, we will press ahead and I will talk us through it. We'll start, again, as always, moving from left to right. So moving from left to right in the x's. I think drawing in, I have these arrows in red that I think are actually very helpful to draw in. So as we move on the curve, if you imagine yourself right in a little minecart or riding it like a roller coaster, you can sort of see, right, we're sort of heading up this slope, we sort of plateau, flatten out, and then we sort of head back up the slope over here. This is important because, right, you can see in this case, this sort of small arrow down here is pointing down and to the left. And I think what happens to a lot of people is your eye gets drawn to an arrow like this that points downward and sort of immediately sort of says, oh, that's decreasing because it's pointing down. In the most basic sense, sure, any arrow that's like pointing down is sort of a decreasing. But for us, because our perspective is, again, moving through this graph from the left to the right, we're sort of always increasing in our x values, right, from negative x's up to 0 up to positive x's. So for us, we're actually coming up this slope, sort of up from down here at negative infinity, again, flattening out and then increasing up. Just talking through that more or less tells us where all the different intervals are. Again, in the x values, we're essentially increasing, right, from negative infinity up to x value -1, right? We're sort of increasing to this coordinate, which is going to be our x is -1. We're flat, which is a constant function, right? So from -1 to +2, that's a 2. So this section is flat, which for us is going to be a constant function, right? This flat horizontal plateau. After that, we head up and to the right again, so this is going to be another section where we're increasing. So we've got two sections where we're increasing from negative infinity to -1, and then also a second section from 2 to infinity. We have a piece in the middle where we're constant from -1 to +2. That's sort of filled in all of our different values, so we never have any intervals where we're decreasing. So we're just going to mark that as a none for now. Ignore this black scribble. That just doesn't have anything to do with anything. Relative maximums and minimums in this case, because we're kind of exclusively increasing or we're constant, if we don't change from increasing to decreasing or vice versa, from decreasing to increasing, we're not going to get any kind of relative max or min. To get, right, one of those like pure peaks, you need it to sort of go up, but then also come back down on the other side, right? Or if you're getting a low point, you're getting one of those valleys, you need to sort of drop to a low point and then turn and come back up to create, right, that sort of minimum value. In this case, we just sort of go up to the flat part and then we're flat and then we sort of go up again. So neither of these like corner points are necessarily maximums or minimums. They're just sort of like pivot points, right, going from kind of one behavior to the next, but it doesn't create a max or a min. So as far as maxes and mins go in this graph, we're just going to mark them both as none.